Hi guys, I'm Tiffany from STEPS Academy Math and Science Center, and today I'll be continuing the last video of this unit. Okay, this unit is not even halfway there, but we're just halfway finishing the paper 1 of organic chemistry. And today I'll be talking about alkene and additional polymer just to wrap up this topic that you need to know for paper 1. So let's go straight to what we need to talk about, alkene. So alkene 4.23, know that alkene contains the functional group of this. I don't know how to say it, but basically functional group is similar to like general formula. All of the thing in alkene have the same functional group, so they all have double bonds. So I said it contains double bond instead of only single bond. It has double bond all the way through. As you can see here in the structure, there are double bond for every single one of them. So that is basically what functional group mean, which mean there are double bond for every single group of them. And that leads to the next point, which is 4.24, know the general formula for alkene. So if you don't remember alkane, it was CnH2n plus 2. So alkene just doesn't have the plus 2, it's just CnH2n, and as I said, N is basically the carbon number, so it literally show you here. There is no methane, okay? There's no such a thing called methane because it doesn't work. So it will only be ethene, propene, butane, pentane, and hexene. So that's basically that, and you need to know all of these. So that is the general formula. It is really important to remember the general formula because they love asking you about what is the general formula of alkene, what is the general formula of alkane. So you got to remember that. I'm just gonna like highlight this for you guys too, so that you remember how it is. 4.25. Explain why alkene are classified as unsaturated hydrocarbon. As I said previously in the last video, alkane are classified as saturated because they only have single bond. So if you're smart enough, you probably guessed it, yes, they are unsaturated because they contain double covalent bond instead of just single bonds. So that is why they are called unsaturated, and that is why they need more energy to break the double bond instead of just single bonds. 4.26. Understand how to draw a structural and display formula for alkenes with up to 4 carbon atoms in the molecule and name the unbranched chain isomers. So I will talk about unbranched chain isomers later. So that is something that I have to mention later on in the video. Is isomers. So that's something that I really struggled so much when I was doing it. So that is why I would be teaching you guys the isomers part, which I feel like is the hardest part. Sorry, as I mentioned, I will be talking about unbranched chain isomers later in the video. So now let's talk about the structural and displayed first. Structural, I just show it here. So here, as I said, in the middle, but you don't break the single double bond, okay? So CH2, CH2, this is ethene, and you put a line there, you can see CH2, double bond CH2. And propene, same thing, you break a bond in the double bond, so CH2, and then double bond in CH3. So you don't have to like this. You don't have to do a single bond like that. You can just link them together because they are a thing after the double bond. So you would just do it as a product, as a thing together. So butene, it will be double bond again, CH2, CH, CH2, CH3, so as you see CH, CH2, CH3. So that is basically that, and I'm pretty sure you guys understand how it goes now with the structural formula and display formula. If you know the display formula, you will know the structural formula because it is really easy to just see it. So yeah. 4.27 is to describe the reaction of alkene with bromine to produce dimer alkanes. So that is additional reaction. And as I mentioned in the introduction, I have like introduced addition reaction to you guys already. So basically, ethene react with bromine, which is another which is a halogen. Ethene plus bromine give you dibromoethane. So it does break the double bond back into single bond, which give you alkane. So C2H4 give you Br2, C2H4 Br2. Why is it additional reaction? Is because it added a new thing instead of sub into something else. So that is why it's called addition reaction and not substitution reaction. And that addition reaction can only happen in alkene. It wouldn't happen in alkane because it doesn't work. And as substitution, it only happens in alkane, doesn't happen in alkene. So they're the same thing. I mean, similar thing, similar idea, but of course, different reaction. So 4.28, describe how bromide water can be used to distinguish between an alkane and alkene. So this is an experiment that you guys would probably do when you're learning this topic. Bromide water can actually distinguish if that reaction the solution is alkane or alkene. So if it's alkane, there will be no change of bromide water. It will stay brown color as they don't have double bonds. So that is why that won't like discolorize any of the bromide water. But alkene, because it has double bond, that's why bromide water will decolorize from brown to colorless. So you should remember brown to colorless, alkene, no change alkane because they don't have double bond. So yeah. So now we'll talk about addition polymer, which is also the topic that I struggled the most when I was learning this unit. I found it super hard, and so was isomer. So that is why I'm gonna spend more time into talking about these now. 4.44. Note that the additional polymers formed by joining up many small molecule called monomers. So that is pretty easy, straightforward. It literally tell you what you need to know at that point. It is formed by joining many molecules called monomers. So addition polymer is a lot of monomer together. And alkene can act as monomer because they are unsaturated. So as you probably have imagined, alkene could not act as monomer because they are saturated. They only have single bond. And that's why they can't act as monomer. 4.45. Understand how to draw the repeat unit of additional polymer, including polyethylene, polypropene, polychloroethene, and polytetrafluoroethene. And I also will mention 4.46 too, so that I will show you guys a diagram where it will probably make more sense. 4.46, understand how to deduce the structure of a monomer from the repeat unit of an additional polymer and vice versa. So I will talk about 4.45 and 4.46 briefly, and then I'll show you the diagram on what you need to know. So 4.45, how to draw a repeat unit of an additional polymer. Basically change the double bond of ethene, propene, chloroethene because they have double bond. So change the double bond in the monomer into single bond in the repeat unit. Add a bond to each end of the repeat unit. You probably have no idea what I'm talking about, but you will know what I'm talking about when I show you the diagram. And when you have to do a monomer from the repeat unit, then it will identify the repeating unit, change the single bond back into a double bond in the monomer, remove the bond from each end of the repeat unit. So you probably still have no idea what I'm talking about, but it's okay. I'm gonna show you pictures of what I am talking about. So here you definitely, guys, you have to remember this part. This part is like so common. It comes up in every single paper that I have done. It will probably ask you how to draw a repeat unit of polyethylene, how to draw polymer of polyethylene, how to draw monomer of ethene. You have to remember all of these 12 because these are like the most important. It comes up every single year. It comes up every single paper one. It is like 3 2 to 3 mark, guys, so you don't want to lose that 2 to 3 mark for something that is really stupid, because 2 to 3 mark give you another grade, guys. So let me just show ethene as an example. So monomer, they will probably be like how to draw a monomer of ethene. So you would just draw that double bond, basically that, CH, CH. So if you don't remember, ethene molecular formula is C2H4, so that's why you just draw the display formula. Basically just draw the display formula. So you'll be like propene. I don't remember that my the monomer, the display formula I learned is like that. So this is basically just sum up the CH3 that was shown here into CH3, if you know what I mean, CH3. Of course you draw that as same thing, it is still monomer, but people tend to draw that because it looks easier to see. So CH2, CH, and then it just sub CH, and then that's CH3 in the top. At the bottom, same thing, doesn't matter. So, and that is and this is the part. Repeat unit is where you break the double bond into single bond, and then you draw the two branches next to it. It's not that hard, I assume. You literally just break the double bond and then put it side by side like that. So you can see, so you can see the difference between monomer and repeat unit. You just basically break the double bond, and yeah. So polymer, even easier. You just drew a bracket and add an n, which means is keep repeating, and that's why you drew an N. And what people confuse the most, and probably I was really confused too when I was doing it, is that I will always kind of forgot that repeat unit is no need bracket, and I thought there was always bracket when I draw repeat unit, and that's why I always draw a bracket when I draw repeat unit, and that is wrong, guys. That is wrong. They will ask you how to draw a polymer of polyethylene. Then you will draw a bracket around it and an N. If it's a repeat unit, you don't draw a bracket, guys. Don't draw a bracket and don't draw an N. You basically just break that double bond, and that's basically what repeat unit mean, guys. And I really have to, I was so frustrated of myself doing that too, because I just don't get it, and I don't know how to do it, and I totally get it, because I was in the same boat as you guys as well. So I wouldn't be talking about chloroethene and tetrafluoroethene, because here it's the same thing as ethene and propene. They're literally the same thing. It's just that there are different product, they are different thing. So basically that. But you guys, this is really important. It comes up every single test paper, as I told you guys. So yeah. 4.47 is explain why problem into disposal of addition polymer, including their instance of an inability to biodegrade, the production of toxic gases when they are burned. So for landfill, that's one of the problem. Dispose of in landfill sites, since they are not biodegradable, so can't break down and causes land to fill up. I'm actually gonna do the rest in a sec, but I want to explain this first. So landfills basically disposes of landfill site, and since they're not biodegradable, so they can break down easily. So that's why they cause the landfill to fill up really quickly, since they can't be break down. So that's why it's gonna cause a lot of problem when there are so much more other additional polymers happen. So alkene is actually not that good for you, and it can form additional polymer. Okay, so the next thing that I want to talk about is incineration. So polymer actually release a lot of heat energy because that when burning it release a lot of heat energy. So it actually contribute into greenhouse gases because of the heat energy, and I'm pretty sure you guys have learned about that. No matter in geo, in biology, in chemistry, you have learned about if it release a lot of heat energy, it will contribute to into greenhouse gases, and greenhouse gases contribute to climate change. So that is why it is really bad for the environment. And also when burning polymer, it will contribute into incomplete combustion. And as I mentioned before, incomplete combustion, it will release carbon monoxide, which is CO, and carbon monoxide is toxic, poisonous for human, and that is why it is really bad. And as I said, it could be really difficult and it is really expensive to separate them each other. If it's recycled, you need a lot of machinery, you need a lot of people to actually do this work, and that is why it is really annoying to actually you need to separate them if it needs to be recycled, and that is why additional polymer is actually not that good for the environment, and that's why we actually as humans should be doing it as less as possible because it is really difficult for this. So now I will be talking about isomers, and one of this is also one of the most famous question of the paper. It doesn't come up like every single paper as a repeat unit, but it come up like occasionally. So and one of their favorite um monomer to us is butane. Okay, and that is because butane actually could be converted in a lot of isomers, and that is why it always us butane. And yes, so butane. If you guys don't remember how butane looks like, I will show you guys how butane looks like. Butane actually looks like this, and this will be called as but1ene. So why will it call but1ene? You'll be like, what the actual heck? So but1ene is because the double bond is on the, so you let's say that they are a group of buddy, okay, and then group 1 is here, so CH2 is 1, CH2, CH2, 3, CH3, 4, and they are a group of 4 buddy. And the double bond you can see is linked to group buddy 1 and 2. And you will always look up to the first one first and the second one, because the first one is probably better, but that's why they are the first one. So that's why it's called but1ene, is because double bond is linked to 1, and that's why it's called but1ene. So what is but2ene? Yes, you guys didn't guess it wrong. But2ene is when double bond is in the middle of the but2ene is when the double bond is in the middle. Actually, you can see why is it also like but1ene when the double bond is at the back, because it could be 1, 2, 3, 4 or 1, 2, 3, 4. It doesn't matter, and that is why when double bond linked to either end, we'll call but1ene, which is also called butene. But you'll be mentioning but1ene in the isomers question, because that would be more obvious to the examiner, knowing that you know what you're talking about. So but2ene is in the middle. You put the double bond in the middle of the isomers, so that's why it's called but2ene. And this is the most complicated one, but usually it will just tell you to draw the structural formula. 10 to less, you need to also write the name. But there are questions that will tell you to write the name sometimes, so that is why it's also good that you know how it is said to be that name. Okay, so basically 2 methylpropene 1ene. Let's skip the 2 first. And then let's group the methyl first. Propone. So let me show you how propene looks like. Propene looks like this, remember? So there's C3H6. Pro1ene, so C3H1, 2, 3, 4, 5, which is fine. And let me just show you this. So B1ene, it looks like that. When you take off one C, it will be propene. And that is why you actually just take away the CH3 and then put it somewhere. And C3 will be H5. It will be H5, but it will still be called propene, and because it still have double bond, and the H's will be like underneath here, so that is why it's still called pro1ene. So that is why it's still called pro1ene, and methyl 2 is because it is, okay, 2 is because it's in the middle, as I told you guys. 2 in the middle, 2 in the middle, and that's why it's called 2. That's why it's in 2, because it's in the middle, and that's why it's 2. If it's at the beginning, it would be like 1, but like you wouldn't say 1 methyl propene because it doesn't make sense. So that's why you just put it in 2. Another common one is probably pentane, is because it is also pretty like also guys, remember alkene isomers could be an alkane, and alkane isomers could only be alkane, and that's something that you have to remember. Alkene isomer could be alkane, but alkane isomer could only be alkane, couldn't be alkene, because it doesn't make sense. So that is why that's the thing that you have to remember as well. Pentane, like if there's a lot of C, lot of H, then there will be isomers happening. So basically isomers is actually pretty simple, except for the name is not that simple. You just put one into one of these. You just put, like, you could put like this. I'm gonna try to draw on this. I'm not sure if I could. So, oh no, I couldn't. Okay, great. So this, the one that I'm circling, basically isomer just mean that they have the same molecular formula, they have the same molecular formula, but they have different structural and display formula. And that's pretty easy. You just change something up. You could change like CH3 and then you put here, and if it's like you need 2, so then you put 1 here and then 1 down there. And the name I probably would think is that is the most hardest, but other than that, the display, but mostly it will just tell you to draw a display formula of the isomers. So you just basically change it up. You basically put 1 into here, down, up, it doesn't matter. And then you, if there's another one, then you can put this up, put this down. It's the same thing, but always put in the middle, because it makes more sense to put in the middle than in either end, or else it would be really hard. You always put in the middle of the one. So in here it would be the third one. You put the CH3 into the top of the third one, put this down, which will come up as this. So you can see they have the same molecular formula. They're all C5H12, but it's just different display formula, and that was what isomers mean. It's just that they have the same molecular formula, but they have different display and structural formula. They wouldn't tell you to do the structural formula for isomers, but they will tell you to do the display formula. And I hope this is not too much, but this is also one of the key concepts, and that's also one of the things that people struggle the most, is to draw the isomers, because it is really difficult to understand. But I hope that by now me explaining, it is not too difficult. So yeah, I hope all of these 3 videos help you guys to go into organic chemistry more easily, because organic chemistry there are part 2, and that is paper 2 stuff. And I hope paper 1 stuff is not too complicated yet, because paper 2 it will be more complicated if you don't understand paper 1. But feel free to look back to the previous video, and I hope these 3 videos help you guys a lot with your organic chemistry knowledge, and it also kind of helped me as well, because I'm going over what I have learned. So yeah, I hope you guys enjoy, and I will see you guys in the next video, and we'll probably talk about another subject, maybe bio, maybe math, maybe physics, but I will see. So I'll talk to you guys really soon.